theorem. We will discuss it from Gauss law or electric field. Okay. So what Gauss says, the total electric flux crossing the closed surface is the total charge enclosed by the surface. Okay. So that is the simple statement. So how much amount of charge available within the enclosed surface, that is equal to number of flux lines coming out of the charges, coming out of the closed surface, that is equal to psi equal to q. Okay, very simply, for example, this is a closed surface. For example, 10 number of charges available within the closed surface. You can find 10 flux lines coming out of the charges. That is a closed surface. Okay, so that is the simple statement he has given. Very useful information. How much charges available within the closed surface, that is equal to the number of flux lines coming out of the closed surface. So this we can explain in terms of mathematical view. So psi, that is the number of flux lines. If you are trying to find it for closed surface, so we can put it closed integral of d psi. Okay, so again mathematics we can apply. Instead of electric flux, we will consider a particular area, how much flux lines are crossing that particular area. So that we can call electric field intensity E. Then we will take, there is a medium property epsilon, then that is called electric flux density D vector. Okay. So if we want to measure the how many flux lines are coming out, we can use this formula. So closed surface integral of D vector dot ds. Okay, all the notations what we are using, that the electric field and magnetic field, electric flux density, magnetic flux, everything is a vector quantity. So closed surface integral of D vector dot ds, this explains on the surface how much flux lines coming out. This is a count, how much flux lines are coming out. What is in the right hand side? Right hand side is the charges. So if you take a volume of charges, then you have to define like this: volume integral of rho v into dv. Okay. So left hand side psi equal to q based on the Gauss theorem. Now we can equate this term with this term. Okay. So that is what I explained here. This is the Maxwell's equation in integral form, the first equation. So closed surface integral of d vector dot ds, that is equal to rho v into dv, volume charges. Okay. So this is the charge available, how much electric flux lines coming out. So source and the effect. Right hand side, all the Maxwell's, all the electromagnetic theory equations we can call cause and effect equation. Right hand side we have a source, volume charge rho v, and left hand side we have the effect. Because of charge, flux lines are coming out in a particular surface, so d vector. Okay, so this is the integral form of Maxwell's equation. Next we can consider in differential form. So we know the Stokes theorem and divergence theorem, where Stokes theorem which relates line integral and surface integral, or we can able to convert from line integral to surface integral, that is Stokes theorem. Then divergence theorem converts surface integral to volume integral, this is divergence. So whenever we want these two theorems, we will use it. We can convert from line into surface, surface to volume integrals by using Stokes and divergence theorem. So what is this theorem says? Left hand side is a surface integral. So previous equation you can see, one side is a surface integral, one side is the volume integral. Okay, so we cannot directly equate. So either we use divergence theorem or Stokes theorem. We will try to equate these two things and we can find it. But right hand side is a volume integral, left hand side is a surface integral. So divergence theorem is the right one to apply, or we can convert the surface to volume. Then both sides volume integral will come and we can remove the volume integrals. So the priority given to volume integral, that is the divergence theorem. So I am going to use surface integral to volume integral conversion by applying divergence theorem. Okay, so I am applying divergence theorem, surface to volume conversion. So divergence of d into rho v. Okay, so now we can write this equation. After this equation we can write integral of volume integral of divergence of d into dv, that is equal to volume integral of rho v into dv. So we can compare both sides volume integral, we can remove the volume integral. So divergence of d, that is equal to rho v. This is a statement which is given. Okay, so already I said integral form of Maxwell's equations explains about the cause and effect. Differential form of Maxwell's equation explains about the nature of the fluid. So what is the meaning of this equation? So rho v is a volume charge. What it can create? It it can create the electric flux equations or electric flux lines, and that is having divergence nature. Okay, so diverging of D equal to rho V. So D stands for electric flux density and rho V volume charge. So charges can create electric flux lines, and that is having divergence in nature. That is the Maxwell's equation in differential form. Okay, next Gauss law for magnetic field. So this is again very simple theorem. What it says, the total flux crossing the closed surface is equal to 0. Okay. So for understanding purpose, first I will consider this diagram. So this is a piece of magnet. Assume this is the piece of magnet, and this particular side is the north pole, and this particular side is the south pole. North pole and south pole. So normally we know the flux lines start from north pole and end in the south pole. This obviously all the magnets will do this process. So if I am taking a closer path, a big box I am taking and keeping the magnet inside, and I am checking how much flux lines are coming out of the box. I am trying to find out. But no flux lines are coming out. That means it is leaving the source. What it is doing? So flux lines start with the north pole and it is taking a curved path or a rotational path and ended in the south pole. So number of flux lines leaving the particular surface, that is equal to number of flux lines entering the surface. So net result of flux lines coming out of the surface is equal to 0. So that is called that is the process of that is the nature of your magnetic flux lines. That means simply we can say magnetic flux lines will curl in nature, it cannot diverge. What is the diverge? Already said. So there is a charge, for example electric field. Assume this is a charge electric field, and the flux line starts from the electric field, keep on moving away. Okay, it never comes back to the source. Okay, this is the nature of electric flux lines, and this is called diverging. Okay, this is called diverging. But what is the magnetic field does? Magnetic field start at north pole and taking a curve path or rotational path coming back to the south pole. So this is the nature of your magnetic flux lines. So magnetic flux lines can curl and it cannot diverge. So Gauss electric field equation, Gauss magnetic field equations simply explaining the nature of electric field line and nature of magnetic flux lines. How these two lines are behaving. Okay.